So I'm going to talk about a little bit about Open5GS, and I believe that for most of you guys, Open5GS is, you probably know it, and it might be really trivial for you to have it running. But still, I think it's kind of good to have a walkthrough. And should you have any questions or comments or whatsoever, just interrupt me anytime. If you want to be recorded, of course. Okay, so Open5GS is a open source core network implementation by Sukjan Lee. And Sukjan is if my open source intelligence is correct, he is a professor in Sungkyunkwan University, or one of the oldest universities in Korea. And as you can see on the browser, it's been heavily developed recently. And everything after version 2 is a combination of 4G and the 5G core network. And before version 2, it's LTE only. And here is the, oops. Okay. Now I know Macintosh is not properly refreshed. So this is the functional block chart or architecture of Open5GS. For everything below this line, it's like it's not core network. It's like your femtocell or cellular modem, and in the green line it's the 4G, and magenta line 5G, and the dashed lines are like okay, I don't really know, and the yellow lines are data, like S1U and N3. That's the data plan. And so let's take a look at the installation. So actually, it has a very good interface for backend. So here, just program everything about the key, the OP key or OPC key, etc. And it's a little bit tricky. Oh, thank you, Howard. So it's a little bit tricky if you want to use IMS. You have to put this configuration here, and you can assign a fixed IP address for NUE here, etc., etc. However, this is just a Node.js implementation, and it's backed by MongoDB. So I don't really think you should use it on anything production level. And however, to my best knowledge, there are a couple of vendors copying Open5GS and made it an actual product for like off-the-shelf merchandise. Okay, and it's pretty easy to install Open5GS. So everything on the screen, sorry. Okay, everything on this screen session is the minimum architecture you have to have when you are running Open5GS. So that's HSS, MME, Pcrf, SMF, NRF, UPF, SGWC, UN. And that's everything you need. So you don't really have to do too much. It's just go to Open5GS. It's just go to Open5GS and make build, make install, something like that. It's building with a Mason and Ninja. So it's not CMake and make install. So that's a little bit different, but not too much different. So for what we have, for example, I usually install Open5GS in the apt Okay, I can see that whatever I'm typing on the screen is not refreshed. So maybe the lesson learned today is don't use the Macintosh when you're sharing with Big Blue Button. Okay. So Open5GS, since I'm in the lab, so I have multiple versions of Open5GS, and sometimes I have to switch back and forth in order to do some experiments. And it's okay. Let me refresh the screen again. So it's pretty straightforward. Everything is in YAML. And for example, for HSS, it's not too complicated. You have to only to assign the MongoDB address and like give it a free. Okay, not good. Okay, free diameter configuration, and we'll talk about that in a bit. And then nothing else. So for HSS, that's everything you need. And then for free diameter, all you have to do is to define the identity and the realms. In the real world, you probably want to assign the FQDN and generate the OpenSSH. The TLS keys. But in the lab, we just don't care about it. And as you can see that I haven't changed much. It's only the IP address that I wanted to listen on. And this TLS cred is written here and it's self-signed, but I'm not really using it. So it's not enforced. And I believe it's not enforced in most of, like here you just say no TLS. Otherwise, you probably have to have a CA to sign it properly. And its MME is just like this. Nothing too special. It's dumping all the information when the UE is attached, and or when the femtosecond cell is connected. And the configuration is kind of simple. All we have to do is to just assign the POMN ID and like change the network name. It's not really complicated. And I'm using 00101 because I wanted to experiment the IMS functions. So I have to assign it to this POMN and get the carrier's privilege. And the next is Pcrf, but to my best knowledge, you don't have to assign anything for Pcrf. And for refresh again, and for SMF, nothing really special. Just assign this IP addresses for SPI, GTP, PFCP, etc. And it uses OGS Tune and OGS Tune 2 for how do I put that? It assigns this IP to your cell phone. So if you're like me, you want to hook Wireshark and capture the packets, just hook on OGS Tune and OGS Tune 2 for what it's worth. And you don't really have to change anything for NRF. And for UPF, it's just the same thing. You assign the IP address and the PDN address and give it OGS Tune and OGS Tune 2. And for SGWC, as far as I remember, there's nothing to be changed. And SGWU, Yeah. Sorry. That's not good. Okay. So for SGWU, you don't have to change anything. And so that's it. It's pretty easy. You just have to have this configuration file slightly changed, and you can have one running core network. Yeah, sorry for the acronyms. I can hardly remember the full name of this acronym. Yeah. Thank you, Howard. And let me go to something like. Okay, so here you can see something like a very minimalistic debugging info, because I haven't changed the debugging level to debug. Otherwise, you get a full screen full of information, like the tunnel number, etc. So in addition to prove it's working, I have a. Oh, okay. So sorry. The things are twofold. So you can ping the IP. You can ping the UE from the core network, like. Yep. Like. Oh, okay. So when it's scrolling, you see the screen is updated. So it's pinging one industrial modem that I have attached to the core network, and this one is a USB dongle. And we can probably disconnect the USB dongle and see something interesting. Like this, the USB dongle. Sorry, no, yeah, like this. I switch off the USB dongle from remote because the devices are in a Faraday cage in the office, and I'm at home right now, so everything has to be remote. And switch it back on. Then for a couple of seconds, we can see like this message. This UE is released because it's going offline, and then in a bit it will go back online. Yep. So which eNode BR am I using? It's a Gemtech. Let me type it. It's a Gemtech commercial off-the-shelf eNode B. Actually, I don't have to change anything. Just it's like Open5GS is implemented in a standard way that any commercial off-the-shelf eNode B should be able to attach to it without any problem. Yeah, bro, I agree with you. There are a lot of nouns, and it's really hard for a newbie like I was. And in order not to make this free talk too dry, because I'm just demoing something. Okay, no response, give up. Sometimes it happens. And I would like to share a little bit how I implemented one of the functions in Open5GS. It turns out it's not too complicated to hack the code. And so Open5GS is a little bit big in terms that it has more than 1,000 of source files, but most of the source files are like converted from ASN.1 expressions, and half of it is like manually written by hand. However, it's very readable. So, for example, there was once I wanted to add a SBC AP message, so that I can pretend to be an SBC AP. So I can pretend to be a CMAS to broadcast emergency warning messages. And so I wanted to add this kind of functionality into Open5GS, and it turns out to be, it's quite easy. So the first thing is to find the event loop, and the actual event loop is a little bit obscure. It's hidden somewhere, but actually all you have to do is to hack this MME event get name, and for some reason you just add one case and return the message name, and so this new message is registered into the MME. Then in the event loop, so when it receives some event, it goes to this switch event ID. And I have cheated a little bit because I did this SBC event checker every time when this event loop runs. So if I'm going to make it really well written, I have to put it here, like slightly before this default case, and add my handler here. And in order to make it really compliant, a normal function like everything else, the best way to do it is to copy this SGS AP event loop, so that I can get things from a socket, probably a SCTP socket, and then extract the information, but I just cheated here. Then in order to build a message, so since I'm not sure how many people here knows about it, so if you don't, just shoot a message in the chat box. So I wanted to send an like presidential alert emergency message to all the cell phones attached to the femtocell. So what I have to do is to broadcast a SIP message, system information block message in SIP 12. And in order to broadcast that message, I have to broadcast a SIP1 message telling the UE that there is a SIP 12 message to be received. And in order to do that, and that kind of message is broadcasted via S1 AP interface to the femtocell or to the eNode B. Then the eNode B will translate it to SIP1, SIP2, and SIP 12. So from the MME's point of view, there's nothing much I have to do. I just have to follow the 3GPP specification, 3GPP 29.168, and form a structure of this message. So, sorry, this message, the message is called S1 AP build write replace warning request. And this function was converted from ASN.1 expression. So nearly everything is there. I didn't have to change too much. The only thing I have changed is between the two command blocks that you have seen on the screen. It was because the femtocell that I'm using, the Gemtech one, was not designed according to the specification, just like many of the femtocells that you can buy on the market. it has to have a warning area list. Even though this warning area list was optional according to 3GPP, you have to have it in order to for this femtocell to broadcast the message for you. So I had to add. Actually, I just copy pasted from the code somewhere else, and it's just like going through the number of TA, the tracking area, and append it to the S1 AP buffer. And in order to build a this SBC message, I have cheated a little bit again because I have hard coded the message that I wanted to broadcast. So you don't really have to send too many things. It's like you just add like this PWS message ID and serial number, number of tracking area, etc. Like repetition period. These are all defined in 3GPP 29.168. So there's nothing really much you have to do. Just follow the spec and fill in the fill the blanks. And what else? And like the code below this SBC handle write replace warning request was already written by Sukchan Lee himself, so I didn't change anything. I have just appended the message that I wanted to send by S1 AP, and just went through the code and see if there's anything I have to change, and it turns out to be there's nothing much. And that's it. Let me just share the pictures here and here. I hope it's well rendered. Sorry. Yep. Okay, so at the top you see the network topology of the experimental network that I have in the lab. It's not that complicated comparing to 3G or 2G networking. It's just like one E node B, then MME, then SGS AP. By the way, in order to send short message, I have to use Osmo MSC.
Just a very short
and the SG.
Sorry, there was a request from Paul if you can zoom in a bit on the graph.
Yeah, sure. Let's see if it renders well. Okay, sorry. Lesson learned, no Macintosh next time. Yep, so the networking topology is quite simple. It's just like you have several VMs or just one VM with a couple of IPs, then it's just pretty simple. And what's beyond Pcrf is the sorry, let me refresh again. So what's beyond Pcrf is the IMS, and we didn't talk about IMS today because I didn't have a chance to make it work for me. It's like my UE can register the voter. My UE can register onto the voter provided by the IMS, and the IMS is the Fraunhofer open source IMS. But I didn't have the chance to make the voice call really work. And the second screenshot is I have two cell phones connected to the base station, and they both showed this emergency alert. It's a presidential alert. And that's it. Do you have any questions, or you want to see any piece of code or configuration?
The display of the phones you showed, this was kind of a screen grab from a real phone that is sitting in your Faraday cage in the lab, right?
Yes, right. Because according to the law, I'm not allowed to broadcast band 3 at band 3. And of course, any form of broadcasting emergency alert to the public is strictly unlawful.
It's fine. Personally, I don't really care for the actual what you do in your place. It's just for the technical reason. I mean, it was a real phone, but it was showing kind of the display with the remote desktop app or so.
Yep, I used SCRCPY to connect to the phone. I mean, connect to two phones at the same time. That's really a good piece of software.
So you were using a real femtocell. Is there a way to kind of have also a working 5G SDR backend that integrates with the stack you have shown?
So we have tried a Microsoft Radiohead and it's working, but I'm not sure about SDR. I have read that it's possible to use USRP 300 series, but we didn't really try.
It should, of course, be possible also with SRS RAN, the software radio systems open source implementation. I used this a very long time ago, the 4G version, SRS LTE, or rather SRS eNode B against Open5GS, but I have no experience with the 5G RAN that they just released.
Technically, I don't think that's any possible. I mean, if you're only talking about the control plane, probably, but the data bandwidth is much higher. I have seen several researchers have made USRP 300 series running with half of the bandwidth, but I'm not really sure because we have paid for a Microsoft Radiohead. It's something like $30K US, and it works.
Well, it's of course always the question, what kind of bandwidth requirements do you have? I mean, you can configure also 5G in relatively small band width, as far as I'm aware.
Yeah, exactly. And there's another reason we didn't want to try USRP. It's because I had some experience with USRP B210 with an external clock source, but with SRS eNode B and USRP, there's always a very high chance to get the clock distorted, and then the UE just simply go offline. I mean, maybe my power source is too dirty, but I have tried some online UPS to make it better, but still the connection was not very stable.
I have a question. Do you try a different VoLTE setup also, like the sorry, I missed there's an open source VoLTE example with an PBX with Camalio. I mean, do you tried it out?
No, the only thing I have tried is the Fraunhofer. And as far as I know, with the latest version of Open5GS, you should be able to use it because they have already fixed the Bearer ID issue.
Okay, thank you.